In our next section, we're going to look at the different load balancing mechanisms that LTM has available and talk about specifically how does it choose from either the nodes or the pool members where it's going to direct traffic to. We'll talk about the difference between making a load balancing decision based on the members of a pool versus the node, and then we'll look at some examples of how we can modify the default load balancing mechanisms and then also verify specifically how the traffic is being distributed from the outside to the inside. Now, as a review of what we talked about before with the status of an object, this is going to be one of the first things that LTM looks at before it makes its actual load balancing decision. So as we saw previously when we were looking at health monitors, we want to make sure that the service is actually available before we forward traffic to that inside particular node. So specifically when we look at the different statuses, before we can actually use the node or use the pool member for load balancing, we want to see ideally that its status is available, which you can see there is the green circle, but it technically could be unknown if we do not have any type of monitoring configured. Now, when the server, or the node I should say, is either unavailable or offline, we're not going to see any new sessions that are forwarded towards it. Where when we look at either disabled or forced offline, we'll see there's some minor differences between those two. One of them is going to allow for persistent connections versus active connections, and the other one, forced offline, is only going to allow the active connections. But again, in any case, the vast majority of time we're going to be using some sort of health monitor here to make sure that we actually know correctly what the status of the node or the pool member is that we want to make our load balancing decision towards. Now, once we get past this portion and we know that the node is available, then we're going to go through our load balancing method. And we'll see that these are going to fall into two major categories that are either statically defined methods or dynamic methods. Now, whether the method is static or dynamic, we'll also see that depending on what the specific method is, we can apply it either at the member level, so member of the pool, or at the node level overall. And we'll see what the difference is going to be between these is based on the fact that the node can belong to multiple pools at the same time. So for example, we might have a web server that's both running clear text and SSL, so it's listening at port 80 and 443, but from the LTM's configuration point of view, those are going to be inside different virtual servers that are calling different pools, which means that they have a membership in multiple pools. Now, at the same time, it's not guaranteed that all the membership to node mappings are going to be on a one-to-one basis. So you might have a case that one physical server is running both a web service plus it's running an FTP server, while other servers might be running just HTTP. So when we make our decision based on the node as opposed to the member of the pool, what this allows us to do is to take into account all active sessions that are happening not only in our local pool, but also for other pools. So let's say, for example, that we're choosing between web server A and B. Well, I might want to take into account, are there already 20 open FTP sessions to server A? And if so, maybe I want to redirect my web traffic to server B. So we'll see there's a lot of granularity that we can get into with the load balancing mechanisms. And when we click the drop-down from the GUI point of view, we'll see it tells us, is this going to be applied based on the member, or is it going to be applied based on the node? Now, as I mentioned, we have two different divisions for the load balancing, either static versus dynamic. And static, as you can probably guess, means that it's not going to take any type of dynamic variables into account, like what's the actual server's performance. Where specifically these are going to be the round robin and the ratio load balancing methods, where the first one, round robin, is the default, where we previously saw we were just going server 1, 2, 3, 4, 1, 2, 3, 4, like in on a one-to-one-to-one basis. Now for the dynamic mechanisms, this is where we can get into a lot more detail, and these can take the server performance into account. So we'll see that there's multiple levels of detail where we could look at things like what are the number of open layer 4 connections versus what's actually going on at the application layer, like how many HTTP GET requests do I have currently open versus looking at just is the server actually available. Now we'll also see that we can run performance monitoring agents on the servers or on the nodes that can report information back to the LTM, like how much CPU free do I have, how much memory free do I have, and then the LTM can use that as part of its weighting to figure out how should it actually distribute the requests to the nodes that are on the inside. But we'll see with our default behavior, as we saw with our regular clear text HTTP pool, the default method is going to be round robin. So the idea here is that your nodes physically on the inside, whether these be physical bare metal machines or virtual machines, that generally they have the same type of physical resources. In terms of either physical CPUs or vCPUs, the amount of physical or virtual memory, the amount of disk I/O, because ultimately those three factors are mainly going to affect the performance of the server serving its responses back to the clients. Now, likewise, beyond doing any of the dynamic methods that look into more details from the servers, we could have a simple design where maybe we have some old servers that we're replacing with new ones, and we don't want to modify a lot of the server-side configuration, like we don't want to install SNMP monitoring agents or really get more complicated with the load balancing, but we could say, I know that this server, the new server, is maybe twice as powerful as the older one, so I'm just going to do load balancing on a ratio of 2 to 1. So instead of looking at any of the upper layer metrics of the actual application, we're just going to do load balancing based on a simple static ratio that we can either define on the node or we can define on the pool member. So let's go ahead and take a look at this back on the GUI configuration, and let's review quickly what our current setup is. So from the main dashboard, if we go down to local traffic and then to network map, we can see that we have one virtual server, which is our public web servers, that has 4 different pool members, which are servers 1, 2, 3, and 4. Now from here, if we go to pools and then go to the pool list, if we go to our internal web servers and click on members, this is where ultimately the load balancing method is going to be set. So we see by default it's chosen as round robin, and if we click the drop down, you can see that there's lots of different methods that you can choose, and we'll get into some more of the details of these as we go on with our examples here. Now, regardless of what the method that we're choosing is, the end result is going to be based on the statistics either at the node level or the pool member level. That's going to show us how LTM is actually making its decision, and then distributing either the number of connections or the bandwidth between the individual servers. So what we want to take a look at to see what's the final result here is either down under pools and then statistics, or if we go under statistics, module statistics for local traffic, then down to either the pools statistics or the nodes statistics. This is where we're going to see the counters that are relevant to our actual verification. So we'll see the number of currently open connections and the number of total requests on a per pool member basis as opposed to the overall nodes. So what we're going to do now is to add an additional service to the LTM so that these servers are load balancing not only clear text HTTP, so regular port 80, but we're also going to add some SSL connections. So if we look back at our topology, what we have now is we have a couple clients on the outside that are on the external VLAN segment. They're routing their traffic to the LTMs on the external segment, so we have the active standby pair, and then from that, the LTM is making its decision based on these 4 pool members that are in that clear text web pool. So in this case now, we're going to take a couple of those members, let's say server 1 and server 2, and we're going to put them in an additional pool that's going to be running HTTPS. So in other words, we're not going to have on a one-to-one basis the members of the clear text pool versus the HTTPS pool. And what the end result of that we'll be able to see is when would you want to choose a load balancing method based on the node versus the pool member. So if we remember our steps to actually create the virtual server, we're going to go down to local traffic, to virtual servers, and click on the plus. We'll call this our public HTTPS servers. We'll say the destination is going to be the same outside address, which was 172.16.0.100. and the service port is going to be 443 for our HTTPS. Okay, then down under the pools, we're going to create a new pool. So under default pool, we'll say that this is our internal HTTPS servers. And we're going to do a monitor as well to make sure that the service is actually there. So we'll do an HTTPS GET. So it's a 443 GET, not a port 80 GET. We'll leave the load balancing method default, which is round robin, and then we'll add our pool member. So we have 10001 at port 443 and 10002 at port 443. So if we finish on the pool, this should bring us back to the virtual server, and then finish on the virtual server. Okay, we can see now the status of both of the pools, the web meaning the clear text and the SSL, both of the service, or the pools I should say, are available, in which if we go to the HTTPS servers and then look at the resources, or actually I want to go to the server list. So let's go to pools, pool list, and under internal HTTPS servers, under the members, we could see what the overall status is, that both of these members are available. So not only are they in the pool, but the LTM is sending the HTTPS GET, they're sending the GET response back, and we know that the service is actually running. Now if we were to go back to the network map, we should see now that we have multiple virtual servers. Again, one of them being for our HTTPS, the other one for our clear text traffic. Now, if we wanted to do just a basic test of how the traffic is being distributed, again, the only thing we really need to do is just to web browse to the virtual server address, which in our case was 172.16.0.100. And if we do a shift and refresh on this page a couple times, we should see that we're just doing our round robin method, which is again going server 1234. So if we go back to pools and then statistics for, let's say, all of these virtual servers, and we should see that pretty much on a one-to-one-to-one basis, fairly closely, that we're distributing the traffic for the web servers pool. Now, in order to generate some additional traffic, I have a basic shell script here that is just going to run through a basic while loop, and it says 100 times we're going to request just the home page, and then we're going to return what the server's name is that's in that particular page. So if you recall from the previous examples, there's a basic index.php file on the root web directory of these servers, and the only thing that PHP function is doing is just returning the host name. So let's go ahead and run this script, and it should output here to the CLI what the return result is. So we can see it's on a fairly equal basis. It's going server 2, 3, 4, 1, 2, 3, 4 over and over and over. And if we look back at our statistics, we should see again that on a pretty even basis, we're doing a one-to-one-to-one-to-one load balancing, or in other words, a round-robin load balancing. Now, you can change the load balancing method in real time. It's not a disruptive change. So in your real deployment, if you're not exactly sure which that you need to choose, you can play around with these to see where you get a little bit more equal distribution, not only on the total number of connections, but you may want to look at based on the bandwidth or based on what are the current active connections, because it really depends on not only what are the physical resources of the servers, but where are they located in your topology. So let's say you have some servers physically on your LAN that the LTM is connected to, but then for additional capacity, maybe you have a virtual private cloud that the traffic comes in from the LTM on the front end, but then routes back over the WAN to some other destination in order to get to those servers. So in that type of environment, you might be better off looking at the amount of active open sessions, because the delay between a local session on the LAN versus having to hairpin the traffic back out and then come back in through the LTM is going to be longer, just based on the physical distance in the network. But we'll see that there's lots of different metrics that we can change in order to affect this load balancing. So if we refresh again, we should see, based on those 100 connections, about 25 a piece, give or take. Okay, so next let's go back to our pool, and let's go to our web servers pool, so the clear text one. And under members, we're going to change this. Let's try the next one, which is the ratio for the member. And again, you can see which of these can you change on a per member basis versus changing on a per node basis or a per session basis, which we'll talk about that a little bit later. But if we were to set this to a ratio based on the member, we can see where the ratio is defined here. So let's say that servers 3 and 4, maybe these are older servers and we don't want to distribute as much traffic to those. In order to give them less weighting, we would raise the ratio value for the other servers, for server 1 and server 2. So let's say in this case we wanted to do ratio load balancing on a 2-to-1 basis. So we'll simply say our ratio is 2 for server 1, and then go back to the pool list. For server 2, likewise, we'll set its ratio to 2. And then if we go back to the pool list, and let's go to statistics, let's go ahead and reset the stats, and then run our script again to pull the servers. So just based on this output, we can see that server 1 and server 2 are getting serviced a little bit more than the other ones. And if we look at our final results of this, and let me make sure maybe that didn't apply. Let's go back to internal web servers, the members, and then I didn't update it here. So let's say ratio member. Then let's go back to our pool list, or actually our statistics, and reset these again. Okay, so now if we refresh, as we can see, now we have 14 to 14 to 8 to 8, or essentially a 2 to 2 to 1 to 1 ratio. Now, as you can imagine, though, this type of static method, just like round robin, doesn't take into any upper layer metrics from the servers. So you might have a server that has twice the number of cores, but that doesn't necessarily mean on a linear basis it's going to have twice the amount of performance. So in a lot of real deployments, you would look at more dynamic methods beyond just doing either the static ratio weighting or the default round robin basis. It really just depends on your particular physical environment that you have. Okay, if we were to go back to now our pool members, and then let's talk about what are some of the other methods. Where specifically, beyond these two static methods, which were again round robin and ratio, for dynamic, some of the common ones would be the least number of connections from a layer 4 point of view. So if we're running regular clear text HTTP, we're just going to look at the amount of open TCP sessions, not the amount of HTTP gets. And this is a clear distinction from how TCP works, that they're not always on a one-to-one basis, where if you're sending 100 HTTP gets, it doesn't necessarily mean that you're going to have 100 open TCP sessions. So this will be one of the difference between the least number of connections versus the fastest response. Where in the case of fastest load balancing, either at the application or the member, we would need to apply a layer 7 TCP profile onto the virtual server. And we're going to come back to profiles in more detail later. But we're basically looking at the application layer. How long is it taking me to send the HTTP GET request and then have the response come back in? Where if we were to look at the least number of connections, that's only based on the layer 4 information. Now, the next two, observed and predictive, these are similar to the ratio, which we looked at the static configuration of. The difference is that the LTM itself is going to automatically update the ratio based on the response coming in from the servers. So it's essentially just going to look at what's the total connection count over time, and if one server has a lot more open connections than the other ones, it's going to move the ratios around, so the server that has more open connections is going to get less new requests as the additional client requests come in. So it doesn't directly talk to the server in terms of polling the number of or the amount of memory, the amount of CPU, the physical resources, but it is going to look at its own statistics, the LTM's own statistics over time, and then try to make a better informed decision based on that. Now, in our particular case, if we were to do something like least connections or fastest, and then look at the load balancing decision based on the node versus the member, this is where we would see if you have multiple physical nodes that are members of multiple pools at the same time, why you might want to choose one versus the other. So let's go back to the GUI, and let's say that we're going to now make our decision based on just the least number of connections. So let's go ahead and update the method, then go back to statistics, reset our statistics, and go ahead and rerun our script here. Now, since the specific get here, the curl request is just an HTTP get for the home page, there's not really an active open TCP session that we're downloading files or other assets from the server, so we shouldn't see that they have a lot of active open connections because we're just requesting one page and then getting the response back in. So in other words, assuming that the servers are about the same speed, which in this case they should be because they're all virtual machines on the same physical host, the end result of least connections is basically the same as round robin, only because we didn't have lots of large file transfers that were going from the server back to the client. But in our particular case, we do have a large file that we can transfer. So if we open up another tab, and let's browse to 172.16.0.100, and that file is simply called file.tar. And we can see the file starts to download now. And if we go back to our statistics page and refresh this, we should see what particular server has multiple open connections. So let's go ahead and refresh this. And we see that server 1 is the only server left that has an additional open session. So if we were to go back to our browser here and refresh this a couple times, what we should see now is that our load balancing method should prefer not to use server 1. So it is going to be used in there sometimes based on the other open connections, but it should be used less often than 2, 3, and 4, because right now if we refresh this again, we should see that these servers currently do not have open sessions. Now, some of these are going to hang out there, and it really depends on what the initiating browser is that you're using. So you'll see that there's some minor differences between using Chrome versus IE or Safari based on how many TCP connections the client actually forms to the server when it's trying to send the gets. But assuming everything is equal from the get requests, like from this curl script, we should see that we're going to try to use server 1 a little bit less here because it has that other open session which we're downloading the file based on. So if we refresh the screen, we should see that server 1 starts to get a little bit fewer connection requests coming in versus 2, 3, and 4. So it's not a huge difference here because we only have one currently open connection, but we will see that there is going to be a difference over a longer term average. Now, the other change here would be that so let's go ahead and cancel this file. If we go back to the pool, and let's now say that we're going to make this choice not based on the member, but based on the least connections per node. So let's update that and now go to our statistics again. So let's go to statistics, module, local traffic, and then go to statistics for the nodes. And let's go ahead and reset these. So as I mentioned before, the difference between making the decision based on the member versus the node is, are we accounting for nodes that are in multiple pools, or are we just looking at the traffic that is constrained to that individual pool? Where in our particular case here, we have 4 nodes, but we have 2 separate pools. 2 of these nodes were specifically our server 1 and server 2. These belong to the clear text web pool, but they also belong to the HTTPS pool. where servers 3 and 4, these only belong to the web pool. So basically, we don't have only 4 members, and we can see this if we go back to the network map, and let's go to the show summary. We have 6 pool members overall, even though these are referencing the same physical nodes on the backend. So now if we're making our load balancing decision based on the least connections per node, there is going to be kind of a normalization between the HTTPS traffic and the regular clear text HTTP. So how we could see this if we were to open up another browser window. And now let's download that file again, but we're going to download it now over HTTPS. So we'll go to 172.16.0.100/file.tar. And we can see now the file is downloading. If we go back to our nodes and go to node statistics, we should now see that we have one currently open session to one of the pool members that was running SSL. Now with the SSL pool, I left that as the default load balancing method, which was round robin. So it should mean that if we were to open up another tab, download the file again, that new connection should land on server 2. So let's open up another window, and we'll go to HTTPS 172.16.0.100 file.tar. And if we refresh our node statistics, we can see now that next session was load balanced to server 2, because from a round robin basis, that's going to be the next one that's in line. Now from our clear text pool, if we go back to local traffic, to pools, pool list, internal web servers, members, we can see now we're looking at the least number of connections, but on a per node basis, not on just the virtual server basis. So if we look at the statistics for the virtual server, or statistics I should say just for this individual pool, notice that there's currently 0 open sessions to any of the clear text devices. So let's reset the stats, go back to 0, and then let's run our script again that's going to call the clear text pages. Now if we look at the end result of this over time, what we should now see is that the total number of connections is going to prefer to be load balanced between servers 3 and 4, because we're not only making our decision based on the members of this pool, we're making the decision for the nodes that are members of multiple pools at the same time. Now you'll see that the behavior is fairly similar for the other load balancing mechanisms. If we go back to internal web servers, members, and then look at the dropdown, as I mentioned, you could look at the fastest for the node versus the fastest for the application, like the application being Apache, where we would look at the HTTP gets and figure out how long is it actually taking me from a delay point of view to send the get and then to get the response back in from the actual server. The difference being is, do we look at just the layer 4 information, which would be least connections, or do we look at the upper layer information like fastest, or do we make a more informed decision based on the actual resources of the server? That would be something like the dynamic ratio for the node or the dynamic ratio for the individual member. So where you would see this typically deployed for the dynamic ratio is when you have some sort of server-side checking, which is basically going to be a performance monitor, where one of the common ones would be just to do SNMP polling to the servers. So there's standard MIBs for the servers to ask them, what's your current CPU utilization? What's your current memory utilization out of the total? Then based on these responses we get back in from the servers, the LTM can automatically adjust its ratios to say, hey, these servers look equal from the outside, but for some reason one of them has 95% CPU utilization. So my next incoming connections, I'm going to try to use the other servers that have less CPU. And from the actual load balancing decision point of view, the way that we're going to do that is just to automatically update the ratio. So as you can imagine though, this one does assume, the dynamic ratio assumes that you have the performance monitor actually running on the node. And what we mean here by a performance monitor is basically a health monitor that is for that specific application. So if we go back under monitors from like our previous example, and we'll go under monitors, and we'll look at let's go to the next page here. We have the SNMP DCA, which is the data collection agent, where essentially what this is saying is that I'm going to pull the server with SNMP version 1 using the community string public, and they should be running this type of SNMP agent, which is basically the default Linux SNMP SNMP daemon. And based on the results that I get back from them, like if the CPU goes over 80%, I'm going to start to lower their ratio down. Now, just like the other monitors that we had previously seen, we can do multiple monitors at the same time, and you can also customize these. So I could say I want to do an HTTP GET in order to check the basic health of the application. So is Apache actually running? But at the same time, I want to know the resources of the server. So either on the pool basis or on an individual node, we could go back to our pools, and let's say for the web service, where right now we're doing the HTTP monitor, we're going to say advanced, and we want to have all health monitors. And in addition to HTTP, we're also going to do the SNMP monitor, which is actually under the node, not under the pool. So let's go to nodes, and then our default monitor. We'll say that we're going to do a basic ping, but we're also going to do the SNMP polling. So if we were to look at a traffic capture, and let me turn off these downloads that we had previously. And let's do a packet capture on the inside interface, that internal VLAN. What we should see here is the SNMP polling from the LTM to the server. So let's do some filters here. Let's say, let's apply a filter that is just SNMP. And we see the LTM, so our active box here, our primary box is .201. It's sending an SNMP polling request to server 1, the GET request, and then we see the GET response coming in from server 1. This particular MIB value, and let's see specifically what this is. It's probably something like the CPU utilization, but the MIB is 1.3.6.141.2021.460, which is, and let me search for that in that page. It's looking for the memory available real, or basically out of your physical memory, what's the percentage, either the percentage or in bytes or bits that the server has free. So we would then see, based on how many connections are going to it, if you're sending 10,000 HTTP GETs, then obviously Apache is going to be using more memory on that physical host or on that bare metal machine. So then based on these responses, assuming that the SNMP agent is running on the server, which in this case we see that it is because we're getting the GET response back in, the ratio for that particular pool should be automatically updated.